All right, mathletes, here's division by radicals. So for any fraction of the form b over square root of a, we can remove the radical from the denominator by multiplying by square root of a over square root of a. Remember, this value is 1, so we can change and we can multiply any fraction by 1 without changing its value. So that's important to do. Whatever we're multiplying to the top, we're also going to multiply to the bottom so we don't change the value of the original fraction we're working with. So let's go ahead and look at example 1 here. So if we have 6 over the square roots of 3, I'm going to identify what I have in my denominator, and it's square root of 3. I'm going to multiply by that, and I'm going to do the same thing on the numerator because I want to make sure that this value here is 1 so that I'm not changing the value of my original fraction. So as I multiply this out, I get 6 square roots of 3, okay, over square root of 3 times the square root of 3 is a square root of 9, or as we simplify that, 6 square roots of 3 over 3. Now I look at my integers and I recognize that 6 and 3, that division can happen. 6 divided by 3 is 2, and I'm left with square roots of 3. Okay, so that would be your final answer for A. So let's look at B. So in B, we're going to recognize our denominator to be square root of 7. So we're going to multiply by the square root of 7 over the square root of 7. Okay, again, this is just 1. I'm not changing the value of my original fraction. So I get 35 square roots of 7. And I'm going to recognize the pattern that square root of 7 times the square root of 7 is just 7. Okay, look at my coefficients. 35 divided by 7 is going to simplify. 35 divided by 7 is 5. Okay, and then I have square roots of 7. Okay, so that's my final answer there. Let's look at another example here. So in example 2, we're thinking about our radical conjugates. So sometimes we have radicals and surds in the denominator that are being added and subtracted. So what we're going to want to do is to get rid of that radical in the denominator. So in our investigation, we looking at radical conjugates. Okay, so a plus the square root of b's radical conjugate is a minus the square root of b, and vice versa. They're conjugate pairs. We can use radical conjugates to simplify fractions of this form. Okay, so just like before, we're going to want to keep that idea that we're multiplying by 1. So if we have 5 over 3 minus square root of 2 here, my goal here is to get rid of the square root in my denominator. Well, in order to do so, I'm going to multiply by 3 plus the square root of 2. Remember, conjugates have different signs in between. And in order to preserve the value of my original fraction, I got to make sure I'm just multiplying by 1. So this fraction here needs to have the value of 1. Okay, so now as I multiply this out, okay, I'm going to be careful here and make sure I have parentheses where I need them. Okay. Okay, my numerator, as I multiply this through, I'm going to do 5 times 3 is 15, and then 5 times the square root of 2 is going to be plus 5 square roots of 2. Okay, my denominator, okay, I get 3 times 3 is 9. Then I get 3 times the square root of 2 is plus 3 square roots of 2. Then I have minus square root of 2 times 3, so I get minus 3 square roots of 2. And we notice this pattern that these middle terms are always opposite of each other and they cancel out. Okay, and then the last one is negative square root of 2 times positive square root of 2. I'm going to get negative 2. Okay, So as I simplify it, these are opposites, they go away, and I get 9 minus 2 is going to be equal to 7 on my denominator. As I think about my numerator, I think 15 and 5 square roots of 2, what do they have in common? Well, they both have a factor of 5 that can come out. So I factor out my 5, and I get 5 times what is 15? That's 3. 5 times what is 5 square roots of 2? I get 5 times the square root of 2. Okay? 5 and 7 here can't be simplified, so therefore that is my final answer. Okay? Let's look at example 3 here. Example 3. So if I want to write this in the form a plus b square roots of 2, I can't have square roots in the denominator. So again, I'm going to employ the similar strategy here. So I have 1 over 5 plus square root of 2 times the conjugate pair of the denominator, which is 5 minus the square root of 2 over 5 minus the square root of 2, preserving the value of my original function because I know this value, something divided by itself, is 1. Okay, so as I multiply this out, okay, 1 times this is just going to be itself, 5 minus the square root of 2. So that was easy. The denominator. So again, I put in my fractions to remind myself I got to double distribute. 5 times 5 is 25. Okay, I'm not even going to worry about my middle pairs because I know they're going to cancel out. Okay, so I'm not even going to write those. My last one is here. Square root of 2 times negative square root of 2. This always does the pattern of negative. Square root of 2 times the square root of 2 is 2. Okay, so as I simplify this, I get 5 minus square root of 2 over 23. So now I'm going to break up this fraction because I need to write it of this form without fractions. Okay, so I can write this and break this down as 5 over 23 minus square root of 2 over 23. Okay, so now my a value is 5 square roots of 23, and I can write this as negative 1 over 23 as my b value times the square root of 2. Okay, so notice that my a is rational and my b is rational. That concludes our notes for tonight. Make sure you highlight any questions and bring them to our next class.